Voyager 1 loses about 4 watts of power each year. But in 2026, NASA shut down another science instrument just to keep the spacecraft alive. The most distant machine humanity has ever built now has only 2 active science instruments, and every decision made on Earth takes more than 23 hours to reach it. The instrument switched off was the low-energy charged particle detector. For nearly 49 years, it had measured ions, electrons, and cosmic rays. Its data helped identify the moment Voyager 1 crossed the heliopause in 2012 and entered interstellar space. Then, its rotating platform began demanding too much power. Engineers could no longer justify the energy required to keep it moving. What remains is a magnetometer and a plasma wave system. One measures the direction and strength of magnetic fields. The other listens to oscillations in the thin ionized gas between the stars. Together, they still reveal an environment no operating spacecraft has sampled from this distance. Voyager 1 was never designed to work this long. It launched in September 1977 for a mission to Jupiter and Saturn. Its power comes from radioisotope thermoelectric generators. Heat released by decaying plutonium-238 is converted into electricity, with no solar panels and no way to refuel. That source was dependable, but it was never permanent. Every year, the generators produce less power, while heaters, computers, radios, and instruments continue to compete for it. The engineering team has switched off non-essential systems one by one. Heaters once considered necessary have been disabled. Science instruments have been retired. Operating temperatures have fallen below their original test limits, yet much of the hardware has continued working. The distance turns each intervention into a 2-day experiment. Voyager 1 is more than 25 billion kilometers away. A command crosses that distance at the speed of light, and confirmation takes another 23 hours to return. If a setting is wrong, there is no instant correction. The team must wait through the full round trip before it knows what happened. But here's the first reason this mission is still alive. NASA is not following a shutdown schedule written in the 1970s. Engineers continually trade heat, power, and risk, testing limits that the spacecraft's builders never expected it to reach. The objective is simple: preserve at least one science instrument for as long as the probe can still communicate. That sounds like a slow and orderly ending, measured in neat, predictable steps. Voyager's recent history has been anything but slow, orderly, or predictable from Earth. On November 14, 2023, Voyager 1 stopped sending readable science and engineering data. The radio signal still arrived. The spacecraft still accepted commands, but the transmission contained a repeating pattern instead of information about its instruments and condition. The problem was traced to the flight data system, one of Voyager's onboard computers. About 3% of its memory had become unusable, probably because a single chip failed. That small, damaged region contained software needed to package data for transmission. Repairing it was not like updating a modern computer. Voyager's memory is measured in kilobytes. Its documentation dates from another era. The team could not replace the chip or restart from a clean backup. It had to divide the affected code into sections, find free locations elsewhere in memory, move those sections, and rewrite references so they still worked as one program. Each change traveled for nearly a day before touching the spacecraft. Each result took nearly another day to reach Earth. In April 2024, 5 months after the failure began, Voyager returned readable engineering data. By June, all 4 science instruments then operating were sending usable data again. And this is where the rescue becomes more than nostalgia. Engineers modified a computer launched before the first commercial mobile phone network existed. Across a distance, light itself needs most of a day to cross. The solution did not restore failed hardware. It rearranged the surviving memory around the damage. Then another aging system demanded attention. Voyager controls its orientation with small thrusters. It must point its high-gain antenna toward Earth with extraordinary precision. Otherwise, its faint radio signal misses the deep space network. Some thrusters had gradually become clogged by residue. A backup set of roll thrusters had been considered unusable since 2004 after two tiny internal heaters lost power. Reconnecting those heaters carried a risk. A change in the spacecraft's power configuration could trigger a fault response and make recovery harder. There was also a deadline on Earth. The 70-meter antenna at Canberra, the only dish with enough power to send certain commands to Voyager, was scheduled for upgrades. During that pause, the team would have less ability to react if the active thrusters deteriorated. In March 2025, engineers commanded the old heaters to turn on. They had only about 30 minutes to judge the result before the heaters would have become dangerously hot. 23 hours later, the telemetry arrived. The temperature had risen. The thrusters, once abandoned for 2 decades, could be used again. The question then becomes uncomfortable. How many rescues can a spacecraft survive when every rescue consumes some of the power it is trying to save? Since the 2024 recovery, the number of operating science instruments has fallen from 4 to 2. That is not a failure of the recovery. It is the price of extending a mission with a shrinking energy budget. Every successful intervention buys time, but none can stop the plutonium from decaying. NASA engineers said their conservation plan could preserve at least one science instrument into the 2030s. That does not give Voyager 1 a fixed expiration date. Its end will be a sequence: fewer instruments, less heat, weaker margins, and eventually a spacecraft unable to gather science or maintain communication. Until then, the 2 surviving instruments still matter. The magnetometer measures the magnetic environment beyond the sun's protective bubble. The plasma wave system can infer electron density by detecting natural vibrations in interstellar plasma. Voyager 2 is also in interstellar space, but it left the heliosphere at a different location. 2 paths give scientists a first comparison of the boundary surrounding our star. The final data will arrive through a signal of astonishing weakness. Voyager's transmitter uses roughly the power of a refrigerator light bulb. By the time that radio beam reaches Earth, the deep space network must separate it from background noise using giant antennas, precise timing, and long integrations. And yet this is not the end of Voyager's journey. When the radio goes silent, the spacecraft will continue moving at roughly 17 kilometers per second. It will encounter the inner region of the Oort Cloud in about 300 years. Crossing that enormous shell of icy bodies could take around 30,000 years. In roughly 40,000 years, Voyager 1 will pass within about 1.6 light-years of the star Gliese 445. That is not a visit. The separation will still be more than 100,000 times the distance between Earth and the Sun. The probe will simply continue through the galaxy, with no target and no engine guiding it. Attached to its side is the Golden Record, a gold-plated copper disc designed as a message from Earth. It contains 115 images, natural sounds, spoken greetings in 55 languages, and music selected from different cultures and eras. Instructions etched onto its cover explain how to play it and locate the solar system using pulsars. The record was never a realistic attempt to contact aliens. Space is too large, and Voyager is too small. Its deeper purpose was to decide what humanity would say if one artifact had to represent an entire planet. But that's not the strangest part of its future. The spacecraft no longer needs to function to complete that role. Its computers can freeze, its transmitter can fail, and its instruments can go dark. The physical object will remain, carrying a record of oceans, weather, animals, mathematics, voices, and music into a future no mission controller can observe. That future can make the present seem insignificant, but the opposite is true. Right now, Voyager 1 is not merely a relic drifting between stars. It is a working observatory with 2 instruments left. Somewhere beyond 25 billion kilometers, a magnetometer and a plasma wave receiver are still converting an unexplored environment into data. The opening number was 4 watts per year. That loss cannot be repaired. What can be changed is how carefully the remaining power is spent, how much science is recovered from it, and how long the final connection survives. Voyager 1 began as a mission to 2 planets. It became the first human-made object to enter interstellar space. Now, its last experiment is endurance. 2 instruments, 1 fading power source, and a signal that still finds its way home. Next, an object from another star system crossed our solar system, and its trajectory gave astronomers only one chance to understand what it was.